Our experiment was about an oscillating spring. Here you can observe our spring, and here you can observe the same spring with an object. In this situation, we can observe the oscillation of the spring with an harmonic motion. The harmonic motion is between two extreme positions, B and C, and A is the median position. So in the first part of your report you have to speak about the harmonic motion. You can take you take the information about the harmonic motion by using your book or from internet, and you can also speak something about you can speak about our aim. Our aim was to demonstrate that during an oscillation of spring, the mechanical energy is constant. I mean, if you can compute mechanical energy in the position B or in the position A or in the C position, the value of the mechanical energy is the same. We are why? Because the forces are only gravitational force and elastic force, and in this case the energy, the mechanical energy is constant. In the second part of our report, you can draw a picture about our experiment. I mean, for instance, you can draw the spring in this situation and the spring during its oscillation. Sorry. In the third part, you can speak about the instruments. We used a chronometer, a meter, and a scale, in Italian bilancia, to measure the mass of the object. Okay. You have also write the sensitivity of our instruments. For instance, the scale, the bilancia, has a sensitivity of 1 gram. The meter had a sensitivity of 1 millimeter. The chronometer had a sensitivity of 0.01 seconds. In this part, you have to speak about the operations performed during our experiment. We measured the length of our spring in this situation without object. Later, we measured the mass of the object. Later, we measured the length of the spring in these three different positions. I mean the extreme position and the median position. And for this measuring, we use the meter. Okay. You have to report your measures in Excel. So here we report the mass, here the length L0 where in this situation. Here the length of during the median position, B position and C position. Later we have to report the period of one oscillation, and later we have to compute the same amplitude of an oscillation and the maximum of the velocity. I mean the velocity in this median A position, because the velocity during the extreme position was 0, of course. You can observe this fact in this way. We can draw the velocity. Okay, so you can observe that the velocity is 0 in the extremes, in extreme positions, and the maximum of the velocity is during the median position. Okay, how to compute the maximum of our velocity? You have to use this formula that derive from the connection between harmonic motion and circular motion. Later we will need K value. K is the elastic constant of our spring. Okay, you can compute this value by using this formula, where you have the gravitational force given by the mass and gravitational acceleration, and you have to consider the variation of the length of our spring between the initial A with respect to initial length of the spring. However, you can put this formula in this cell, and you have the K, the elastic constant of our spring. Okay, later you can try to compute the mechanical energy in 3 different positions. We have the aim of our experiment was to demonstrate that the mechanical energy during 3 different positions was the same. How to compute the mechanical energy? You have to sum kinetics energy and potential energy in the same instant. For instance, in the B position, the extreme B position, the velocity was 0. Okay, so the kinetic energy is 0. During this situation, the elastic potential energy is given by this formula, where we use the factor 0.5, the K factor, and the difference between the length of our spring in the B position, okay, here, and with respect to the length of our spring in the initial situation. Okay, this is the formula to compute the potential energy. The gravitational energy was 0 in the B position because we can consider with the B position as a reference level. Okay, during the A position you have to compute at the same way the mechanical energy, but in this case you have to compute the kinetics energy by using the velocity that we computed in this part of our Excel frame. And here you can see the formula to compute the elastic potential energy, and here you can see the formula about the gravitational potential energy. And in this case you have a value different, it isn't 0, it is not 0, because in the A position there is a distance and height between the reference and when the potential energy was 0. In this case the potential energy is given by this formula. Okay, mass 9.8 and the height in the A position. Okay, in the C position you can perform a similar computation. The velocity was 0. Okay, so the kinetics energy is 0, and later you can compute in the potential energy, potential elastic energy, and the gravitational energy. Okay, in this experiment that was my experiment, actually we have the same value because we have to consider the errors. Okay, so if you consider that measures are affected by errors, you can consider constant the mechanical energy in these 3 different positions. So we actually demonstrated that the mechanical energy in this situation during the oscillation of our spring was constant. You have to write you have to report the table of the measured quantities and computed quantities in this part. Okay, you have to describe the formulas in this part, the formulas used to compute all these quantities, especially mechanical energy, and you don't need to report a graph, so you can delete this part. And in the final part you have to write something about the conclusion. You can write that actually mechanical energy was the same in the 3 different considered position. Okay, also you can try the calculation of the errors. Okay, and to read something about this part you can go here